You've seen the diagrams. A nucleus in the center, electrons orbiting around it like planets, and between them, nothing. Empty space, vast proportional emptiness. You've heard the analogy. If the nucleus were a marble, the electron would be a mile away. The atom is mostly empty space. That sentence is in every introductory science book. It's repeated so often it feels like truth. And it's the first lie you need to abandon. Not because the proportions are wrong, they're roughly correct, but because the analogy is poison. It smuggles in an assumption that doesn't belong. It makes you think of atoms the way you think of the solar system. Objects separated by emptiness, things with edges floating in a void that exists independently of them. That picture is not a simplification. It's not a useful approximation. It's a conceptual trap. Because when you ask what's between the nucleus and the electron, you're already assuming there is a between. You're assuming the electron is over there and the nucleus is over here, and there's a gap in the middle that could, in principle, contain something or contain nothing. But the electron is not over there. It's not anywhere. Not in the way you mean. The nucleus is not a marble. The electron is not a planet. And the space between them is not empty, because there is no between to be empty. The question itself is malformed. It's like asking what's north of the North Pole. The words fit together grammatically, but they don't correspond to anything real. Feynman understood this. He didn't avoid the question because it was too complicated. He avoided it because the question tries to force a classical picture onto a quantum reality. And quantum reality does not have gaps. It doesn't have separation the way you think it does. What it has instead is something stranger, something you'll need to unlearn your spatial intuition to even begin to approach. The atom is not mostly empty space. The atom is mostly something you don't have a word for yet. You think fields are like fog, something that fills space. A substance spread out across a region, thinner here, denser there. The electromagnetic field around a charge. The gravitational field around a mass. You imagine them as invisible stuff occupying the gap between objects. That's still the wrong picture. A field is not in space. A field is not a thing that exists within the container of space. Space is not a stage, and fields are not actors on it. The field is the only thing there is. This is not poetic. This is the ontology of modern physics. When you look at an atom, you are not looking at particles embedded in a field. You are looking at disturbances of the field. The electron is not a particle traveling through an electromagnetic field. The electron is a localized excitation of the electron field. The photon is not a particle of light moving through space. The photon is a ripple in the electromagnetic field. Every particle you've ever heard of is a field doing something. A vibration, a spike, a mode of oscillation. There is an electron field everywhere in the universe, always. When you see an electron, you're seeing a place where that field is excited. When you don't see an electron, the field is still there. It's just in its ground state. The field doesn't need the particle. The particle needs the field. So when you ask what's between two atoms, you're asking the wrong question. You're imagining two separate things with a gap. But there is no gap. There is one electron field extending through both atoms, one electromagnetic field coupling the charges, one quark field underlying the nuclei. The atoms are not separate islands. They are overlapping patterns in the same underlying fields. You think of the universe as objects in space. But quantum field theory says the universe is fields, and space is just the mathematical structure that lets us talk about where the fields are excited. The electron in one atom and the electron in another atom are not two things separated by space. They are two excitations of the same thing, the same field. The thing you call between is not a void. It's the field in a different state. And the field is never off. It's never absent. It's the fabric, not the object. You want to know where the electron is, right now, at this exact moment. You think that's a reasonable question? You think the electron must be somewhere, even if you don't know where, even if it's difficult to measure. You think location is a property things have, whether you look or not. Quantum mechanics says no. Not, we don't know where it is, not, it's moving too fast to pin down. The electron does not have a location until you measure it. And this is not ignorance. This is not a gap in human knowledge. This is the structure of reality. The electron is described by a wave function. And the wave function is not a probability cloud representing where the electron might be hiding. The wave function is the electron. It is spread out. Not spread out like a smear of butter, spread out like a wave on a string. The electron exists in a superposition of positions, all of them, at once. This is not metaphor. When the electron is bound to an atom, its wave function extends in all directions. It doesn't have a sharp boundary. It fades. The probability of finding the electron drops off with distance, but it never reaches zero. Not at 1 nanometer, not at 1 meter, not ever. The electron in a hydrogen atom has some probability of being detected on the other side of the room. Vanishingly small. Absurdly unlikely. But not zero. The wave function has a tail that extends infinitely. That means every electron in your body has a wave function that overlaps with every electron in the chair you're sitting on, with every electron in the wall, with every electron in the moon. You are not separate from your surroundings in the way you think you are. The boundaries you perceive are not boundaries in the wave function. They are boundaries in the probability density, places where detection becomes unlikely. But unlikely is not the same as absent. So when you ask what's between two atoms, the answer includes this. The electrons of both atoms are already everywhere. Their wave functions overlap. They are not separated by a gap. They interpenetrate. They exist in superposition across the space you thought was empty. The electron is not a dot. It is not a particle sitting in one spot. It is a field excitation with no definite location. And when you stop measuring it, it stops having a place. What's between the atoms? The atoms themselves. Or rather, the fields that the atoms are made of, extended and overlapping and refusing to be cleanly separated. There is no between. There is only the wave function. And the wave function does not respect your intuition about gaps. You think vacuum means nothing, the absence of everything, perfect emptiness. You evacuate all the air from a chamber, remove every atom, every photon, every particle, and what's left is nothing. Pure void, silent, still, inert. Physics tried that picture. It didn't survive. The quantum vacuum is not empty. It cannot be empty. And this is not a technicality. This is not physicists playing with definitions. The vacuum has energy. It has structure. It seethes. Take a region of space. Remove everything, every atom, every particle, every field excitation. You are left with the ground state of all fields. And the ground state is not zero. It cannot be zero. The Heisenberg uncertainty principle forbids it. Energy and time are conjugate variables. You cannot have a field sitting perfectly still at exactly zero energy for any duration of time. There must be fluctuations. The field must oscillate, even in its lowest state. This is called zero-point energy. Every field, everywhere, is vibrating, even when there are no particles, even in the vacuum. The electromagnetic field fluctuates. Virtual photons blink in and out of existence. Electron-positron pairs emerge for impossibly brief moments, then annihilate. They are not real in the sense that you can detect them directly, but they are real in the sense that they have measurable effects. The Casimir effect proves this. Place two metal plates very close together in a vacuum. The vacuum between them has less energy than the vacuum outside because the plates restrict which wavelengths of virtual particles can exist in the gap. The energy difference creates a force. The plates attract each other. You can measure it. The vacuum pushes. This is not theoretical. This has been measured in laboratories. The emptiness between objects exerts pressure. So when you ask what's between two atoms, part of the answer is this: a boiling sea of quantum fluctuations, virtual particles, field oscillations that never stop. The vacuum is not a passive void. It is the lowest energy state of something that cannot stop moving. You think of empty space as nothing, but nothing is not a physical state. Nothing is not allowed. The universe does not permit true emptiness. The fields are always on, always fluctuating, always doing something even when they appear to be doing nothing. The space between atoms is not quiet. It is not still. It is screaming with activity you cannot see. And that activity is not incidental. It affects how particles behave. It shifts energy levels in atoms. It changes the mass of particles through interactions with the vacuum itself. What you call empty is not empty. It is the quantum foam, the zero-point field, the irreducible restlessness of reality. And you are immersed in it, always, everywhere. The void is not a void. You want to know where the atom ends. You want a boundary, a surface, a line you could draw, even in principle, that separates the atom from the not atom. You think objects have edges. That's what makes them objects. The atom does not have an edge. This is not because the edge is blurry. It's not because we lack precision. The atom does not have an edge because edges are not a thing wave functions do. The electron cloud around a nucleus is described by probability density. It tells you the likelihood of detecting an electron at any given point. Near the nucleus, the probability is high. Farther out, it drops, but it drops asymptotically. It approaches zero. It never reaches zero. You cannot point to a distance and say the atom ends here. There is no threshold, no cutoff in nature. The wave function decays exponentially, smoothly without interruption. At 1 angstrom, there's a high probability. At 10 angstroms, much lower. At a meter, incomprehensibly tiny, but not zero. Never zero. This means the atom fades into its surroundings. It does not stop. It dissolves. The boundary you imagine is a human convenience, a place where we decide the probability is low enough to ignore. But that decision is arbitrary. Nature makes no such decision. So when two atoms are near each other, their electron clouds overlap. Not metaphorically, literally. The wave functions add, interfere, create bonding and antibonding orbitals. The electrons are no longer describable as belonging to one atom or the other. They belong to the system, to the molecule, to the shared wave function that extends across both nuclei. You cannot ask where one atom ends and the other begins, because there is no place where that happens. The transition is continuous, smooth. There is no gap to measure, no space between, and it gets worse. Because even a single isolated atom has no edge, you cannot define between for two atoms. Between implies two separate things, but the atoms are not separate, not in the wave function. They are probability distributions that interpenetrate, overlap, and merge. The idea of separation is something you impose on the math after the fact, by drawing imaginary boundaries where none exist. The atom is not a thing in space. It is a pattern of field excitations with no clear beginning or end. You are not made of distinct, separate atoms. You are made of overlapping wave functions that we carve into conceptual pieces because that's how our minds work. But the carving is not in nature. Nature is continuous, smooth, boundaryless. What's between atoms? Nothing is between them because they do not have edges to be between. They bleed into each other. They are not separate entities waiting in isolated pockets of space. They are ripples in a single, continuous field structure that we label with discrete names because language requires it. But reality does not. Feynman was asked once to explain how magnets work, how the electromagnetic force really operates, and he refused. Not because he didn't know, but because he knew the person asking wanted a story, a mechanism, a picture they could hold in their mind that would feel like understanding. And Feynman knew there was no such picture. He said you can't explain it in terms of anything else you're familiar with. Because the electromagnetic force is not like anything else. It's fundamental, irreducible. You can describe it mathematically. You can predict its behavior with stunning accuracy. But you cannot visualize it in a way that satisfies your intuition, because your intuition was built for a world of medium-sized objects at human speeds, not for quantum fields. This is not a failure of physics. This is physics telling you something about reality. Reality at the quantum level does not offer you a picture. It offers you a mathematical structure. And the structure works. It predicts experiments to 12 decimal places. But it does not translate into the kind of mental image you want. When you ask what's between atoms, you are asking for that picture. You want a story, a mechanism. You want to know what the gap is made of, as if it were made of something you could imagine. Particles or fields or energy or space itself, but something. Something you could draw. Something you could rotate in your mind and feel satisfied by. Feynman would tell you there is no such picture. Not because we haven't found it yet. Because it does not exist. The question assumes reality is made of visualizable pieces. But quantum field theory says reality is made of mathematical objects. Operators on Hilbert spaces. Fourier transforms of momentum states. Symmetry groups. These are not pictures. They are structures, and the structures do not reduce to anything simpler. The electron is an excitation of a field. The field is described by an equation. The equation works. But the equation does not give you a mental image of what the field is made of, because it is not made of anything. It is the thing other things are made of. And you cannot visualize it the way you visualize water or air or marbles, because those are emergent, classical approximations. The field is fundamental. Feynman admitted this openly. He said nobody understands quantum mechanics, not in the sense of having a satisfying internal picture. You can learn the math. You can use the theory. You can make predictions, but you cannot understand it the way you understand a clock and where you see the gears and feel satisfied. And his answer to what's between atoms would be this. The question is asked in the wrong language. Between implies separation. Atoms are not separate. They are patterns in a field. The field is everywhere, always. What's between them is the field, and the field is not empty space. It is not filled space. It is not space at all. It is the thing whose excitations create the illusion of space and separation in the first place. You want an answer that comforts you. Feynman offers you honesty instead. The universe does not owe you a picture. It only owes you the math. And the math says, your intuition is wrong. You think you are distinct, a self-contained system. Your atoms here, the chair's atoms there, a clear division between inside and outside. You think your body ends at your skin, that there is a you and a not you, and a boundary separating them. But if atoms have no edges, then neither do you. Your electron clouds do not stop at your skin. They extend outward. They overlap with the air molecules around you, with the chair, with the floor, with everything you think of as separate. The wave functions interpenetrate. There is no clean cut, no place where you end and the world begins. This is not mysticism. This is quantum mechanics applied honestly. If the electron in an atom has a wave function that extends infinitely, then every electron in your body has a wave function tail reaching into the environment. The probability is low, but low is not zero. And in quantum mechanics, non-zero probability means the state is real. It contributes to the superposition. You are entangled with your surroundings. Not poetically, physically. Electrons in your body have interacted with photons from the sun, with air molecules, with the chair, with the ground. Those interactions create quantum correlations. Entanglement. Your wave function is not separate from the wave function of the room. They are part of a larger joint state. The universe does not consist of separate objects. It consists of one wave function, one quantum state describing everything. Every particle, every field, every degree of freedom, all in superposition together. We carve that state into pieces. We talk about this electron and that atom and this person. But the carving is conceptual. It is a map we draw because we cannot hold the full state in our minds. The territory does not have those lines. Separation is a classical illusion. It emerges when you stop paying attention to the quantum details, when the entanglement becomes so complex that it looks like decoherence, when the correlations wash out into statistical noise, then the world looks classical. Then objects look separate. Then you look distinct. But you are not fundamentally. Feynman knew this. He knew quantum field theory describes a universe with no gaps, no true separations, just continuous fields in different states of excitation, creating the appearance of particles, the appearance of boundaries, the appearance of distinct things. What's between atoms? Nothing is between them. They are not separate. What's between you and the world? Nothing is between. You are not separate. This is the answer that breaks your mind. Not because it is complicated, because it is simple. And the simplicity destroys the one intuition you've never questioned, that you are a thing distinct from other things, occupying a separate region of space. You are a pattern, a temporary localized excitation of quantum fields. And the fields do not stop at your skin. They are everywhere. You are everywhere. Fading into improbability, but never into absence. And the question was wrong. The separation was never real. And once you see that, you cannot unsee it. You are not in the universe. You are not separate from it. You are it. A part of a seamless whole that has no between, no gaps, no divisions except the ones you imagine. And imagination is not enough to make them real.